When it launched on Christmas Day in 2021, the James Webb Space Telescope, or JWST, was 11 years late and almost $10 billion over budget. Accusations of mismanagement had brought the project, a collaboration between the space agencies of America, Europe, and Canada, to the brink of cancellation. But scientists were confident that all would be forgotten once the first images were beamed back to Earth. Thus far, the stunning pictures have justified their confidence.
The whole concept of the James Webb Space Telescope was to see the universe the way no previous telescope had ever seen it.
Using NASA's James Webb Space Telescope, astronomers even have discovered potentially universe-breaking ancient galaxies which, until now, widely accepted science said couldn't exist. 6 galaxies estimated to have been present between 5 to 700 million years following the Big Bang event, 13.7 billion years ago, are sending shockwaves through the scientific community. Should further investigation confirm their existence, the basic rules of cosmology will need to be torn up and rewritten.
We don't really expect anything to be there, and these new objects appear to be in that gap. And so this would completely force it to completely rethink what's going on back then.
Join us as we dig deep into how James Webb's images shatter our understanding of the universe. Looking back in time might sound like a strange concept, but it's what space researchers do every single day. Our universe is bound by the rules of physics, with one of the best-known rules being the speed of light. And when we talk about light, we're actually referring to all the wavelengths across the electromagnetic spectrum, which travel at around a whopping 300,000 kilometers per second. Light travels so fast that in our everyday lives, it appears to be instantaneous. Even at these breakneck speeds, it still takes some time to travel anywhere across the cosmos. When you look at the moon, you actually see it as it was 1.3 seconds ago. It's only a tiny peek back in time, but it's still the past. It's the same with sunlight, except the photons, or light particles, emitted from the sun's surface travel just over 8 minutes before they finally reach Earth. Our galaxy, the Milky Way, spans 100,000 plus light years, and the beautiful newborn stars seen in JWST's Carina Nebula image are 7,500 light years away. In other words, this nebula, as pictured, is from a time roughly 2,000 years earlier than when the first ever writing is thought to have been invented in ancient Mesopotamia. Anytime we look away from the Earth, we're looking back in time to how things once were. This is a superpower for astronomers because we can use light, as observed throughout time, to try to puzzle together the mystery of our universe. Space-based telescopes let us see certain ranges of light that are unable to pass through Earth's dense atmosphere. Typically, the Hubble, which famously launched in 1990, has played a key role in pushing scientific understanding across numerous areas of astrology and cosmology. From the exploration of dark matter to determining the true age of the universe, Hubble has not only contributed to answering some of the biggest scientific questions of our time, but also revealed previously unimagined discoveries. Seemingly, the newer James Webb Telescope is determined to continue this tradition. Its improved infrared light detection technology lends it 100 times more powerful than the Hubble, allowing novel and deeper examinations of space and the origins of the universe. As the universe continually expands, light traveling from objects in distant space towards Earth is stretched in a process known as redshift. The redder the light detected, the further it has traveled. Thus, redness is a proxy for age. Using these technologies, scientists have been able to re-examine regions seeing up to 13.5 billion years ago, approximately 200 million years after the Big Bang. But what have they found? A consensus-shattering discovery. In July 2022, a patch of space adjacent to the Big Dipper constellation was re-examined using the Webb telescope. According to Joel Leja, or Leah as is sometimes pronounced, assistant professor of astrophysics at the University of Colorado and co-author of the Nature paper detailing the findings, high-resolution images obtained contained 6 blotches of extremely, unusually bright and red dots. Calculations suggest these objects are 13.3 billion light-years away. But the age of the objects alone isn't what makes them outstanding. The measured intensity of the light detected is far larger than that emitted by a single point source, like a bright star or a supernova, but is actually galactic in scale. It was initially considered a mistake, as there are numerous ways telescopes can incorrectly perceive objects. For example, gravitational lensing is a phenomenon first postulated by Einstein, detailing how light can be bent through gravitational fields as it travels through space, making it appear brighter than it actually is. Through investigation, gravitational lensing has been dismissed, as have other ideas explaining away the phenomenon, leaving scientists to explore one glaring explanation. The data observed is evidence supporting the existence of mature galaxies much earlier than scientific consensus can explain. In other words, it's breaking the rules, but how? Current scientific consensus holds that galaxies only began to form about 350 million years after the Big Bang. Known as dwarf galaxies, they are relatively tiny, forming through small clouds of stars and containing up to 100 million stars. Mature galaxies like our own Milky Way, containing a minimum of 100 billion stars, were thought to take far longer to come into existence. The newest galaxies observed by the Webb telescope are proposed to contain populations of 10 to hundreds of billions of stars, 500 million years after the Big Bang, a time frame previously thought as impossible. Initial indications suggest that the largest of these galaxies is comprised of mass 1 trillion times greater than that of our Sun, or 10 times that of our Milky Way. Scientists working on the data have been extremely clear about their surprise. Erica Nelson, a professor of astrophysics, said, "It's bananas," further clarifying that you just don't expect the early universe to be able to organize itself that quickly. These galaxies should not have had time to form. Despite the excitement amongst the scientific community, caution is being exercised in jumping to conclusions. That said, the implications for cosmological understanding are far-reaching. Simply put, should findings prove to be correct, galaxy formation has been far more prolific than can currently be explained by the basic rules of cosmology. The best model we have for the evolution of the universe is the Big Bang. According to this model, the universe started as an infinitely dense, infinitely hot complex of space, time, matter, and energy. From these initial conditions came the expansion of space-time. This led to everything we see today: galaxies, planets, people, everything. The Big Bang is a pretty grand idea. It leaves astronomers with a lot of details to unpack, starting from the universe's earliest stages, 1/zillionth of a second after the expansion started, to the cosmos we see 13.8 billion years later. One detail astronomers have long pondered is what happened after the formation of the cosmic plasma of hydrogen and helium. This took shape about 300,000 years after the Big Bang, but before the full assembly of galaxies. For years, scientists have built their Big Bang models on the idea that the universe continually cooled as it expanded. This allowed some interesting things to happen along the way. After a few 100,000 years, for example, the infinite fireball of creation — it's not really a ball, it is all of space-time — would have cooled to a temperature that allows protons and electrons to move slowly enough to latch onto each other and form the first atoms of hydrogen. Hydrogen formation marks a critical transition from the infant universe. Once lots of hydrogen exists, the relation between matter and radiation changes dramatically. Some kinds of light that were locked into a tightly coupled dance with matter are suddenly freed to wander the universe unhindered. Other kinds of light are suddenly trapped. This happens to strong ultraviolet photons, the stuff that gives you a sunburn. Hydrogen atoms are like UV sponges. They love to absorb UV light particles. UV light has a hard time traveling freely through the universe once hydrogen forms. Any UV light that is emitted gets absorbed by neighboring hydrogen atoms. The presence of large amounts of hydrogen means the universe is dark, at least in terms of ultraviolet light. In fact, scientists call the period after hydrogen formed as the Dark Ages. The universe we now live in, however, is far more transparent. This means that eventually the Dark Ages must have ended. Astronomers have long believed that the first generation of stars, and black holes, helped end the Dark Ages. When the young universe matured enough to allow stars to form, perhaps a few 100 million years after the Big Bang, the light they emitted was powerful enough to tear apart hydrogen atoms floating in space. The light ionizes the hydrogen, pulling the atom's sole electron away from the single proton in its nucleus. As the universe begins to fill with stars, the amount of hydrogen gas in space drops. But the process of birthing new stars happens extremely slowly. The proposed theory suggests the Milky Way gives birth to approximately 6 to 7 new stars per year. However, for the aptly named universe-breaking galaxies to exist within the newly proposed time frame, they would have been forming hundreds of stars a year over hundreds of millions of years. Potentially, the Dark Age was not so dark after all, and the abundance of heavy elements such as hydrogen and helium required for mature galaxy formation was much higher than has been suggested. So, after all, further investigations into the 6 universe breakers are required. Astrologers are confident that the Webb telescope's near-infrared spectrograph, or NIRSPEC, which surveys temperature, mass, and chemical composition of target objects, is more than capable of providing a conclusive answer regarding their existence. While waiting to hear if the current cosmological rulebook is about to be torn up and whether our fundamental understanding of the origin of the universe is about to change, let's continue to uncover the latest discoveries of James Webb. Researchers are aware of more than 5,000 exoplanets, worlds that orbit stars outside of the solar system. Despite this, very little is known about most of them. The JWST is giving us access to these other worlds as never before seen. New data from NASA's James Webb Space Telescope shows the atmosphere of a rocky exoplanet in the TRAPPIST-1 system, revealing bad news for life. Astronomers using JWST were able to calculate the amount of heat energy coming from TRAPPIST-1c, revealing that the dayside temperature of the rocky world is about 225 degrees Fahrenheit, that's 107 degrees Celsius, the coolest rocky exoplanet ever characterized. At this temperature, the exoplanet's atmosphere is likely extremely thin, if it exists at all, according to a statement from NASA. Located just 40 light-years from Earth, TRAPPIST-1c is one of the 7 rocky planets orbiting an ultra-cool red dwarf star, the most common type of star found in our Milky Way galaxy. Therefore, studying this exoplanet system helps astronomers better understand if these types of stars can host worlds able to support life as we know it here on Earth. As Sebastian Ziba, first author of a new study announcing the results, and a graduate student at the Max Planck University for Astronomy in Germany, said in the NASA statement, "We want to know if rocky planets have atmospheres or not. In the past, we could only really study planets with thick, hydrogen-rich atmospheres. With Webb, we can finally start to search for atmospheres dominated by oxygen, nitrogen, and carbon dioxide." While the worlds orbiting TRAPPIST-1 are similar in size and mass to the inner rocky planets in our own solar system, the composition of the exoplanets' atmospheres remains unclear. That's where JWST comes in. The telescope's powerful mid-infrared instrument, or MIRI, helps astronomers characterize rocky exoplanets such as TRAPPIST-1c. Initially, astronomers thought TRAPPIST-1c might have a thick carbon dioxide atmosphere like Venus, given it is about the same size and receives a similar amount of radiation from its host star as Venus gets from the Sun. However, red dwarf stars like TRAPPIST-1 emit bright X-ray and ultraviolet radiation that can easily strip away a planet's atmosphere. It's also possible that, at the time the exoplanet formed, there was not enough water, carbon dioxide and other volatiles available to make up an atmosphere, according to the statement. Using MIRI, the research team compared the brightness of light emitted by TRAPPIST-1c as it moved behind its host star to when the planet was beside the star. By doing this, the team was able to calculate the amount of mid-infrared light emitted by the planet, which is directly related to its temperature and, in turn, its atmospheric composition. The emissions observed from TRAPPIST-1c suggest a lack of carbon dioxide gas that would have otherwise absorbed the light coming from the planet. Sebastian Ziba said, "Our results are consistent with the planet being a bare rock with no atmosphere, or the planet having a really thin CO2 atmosphere, thinner than on Earth or even Mars, with no clouds." Given that TRAPPIST-1c lacks a thick atmosphere, the astronomers suggest that it may have formed with relatively little water, or any other form of components necessary to make a planet habitable. It is extraordinary that we can measure this, study co-author Laura Kreidberg, also of the Max Planck Institute for Astronomy, said in the statement. There have been questions for decades now about whether rocky planets can keep atmospheres. Webb's ability really brings us into a regime where we can start to compare exoplanet systems to our own solar system in a way that we have never before been able to. In addition, the JWST is also supplying a clear look at the solar system we call home, on the outer spiral of the Milky Way. Recently, the Webb telescope has captured its first incredible images of the gas giant Saturn, but they aren't quite ready for the public yet. The raw images of Saturn were revealed on the unofficial website JWST feed, which contains every piece of data collected by the powerful space telescope since it began operations in mid-2023. Currently, the images of the ringed gas giant taken by the James Webb Space Telescope between June 24th and 25th exist as raw, unprocessed black and white data. But even in this unbaked state, they hold the promise of stunning new views of the planet and its famous ring system. The raw images act as a tantalizing tease of what should be an incredible, unprecedented look at Saturn after they are fully processed. Like any modern telescope, the JWST does not take color images like a film camera would. The European Space Agency, or ESA, which operates the telescope with NASA, said in an unrelated statement about how its images are produced. The images that are beamed back to Earth are in black and white, and much more work is done on them after they are received to create the spectacular vistas we are familiar with. This process is not just necessary to make them look good, but also to highlight a variety of useful scientific information. The ESA explained that the black and white exposures, or frames, reflect the number of particles of light or photons that have fallen on the detector of one of its instruments, such as the NIRCam and the MIRI. A pixel collecting more light during the results is an efficient way of measuring the light collected with high accuracy, something the ESA said is critical for deriving scientific results from JWST data. In these raw images of Saturn, which were captured by JWST's NIRCam, the second largest planet in the solar system is both seen as a glowing and fairly indistinct shape and as a clear dark disk representing the planet with a bright band representing its ring system. The images were taken on behalf of a project led by the University of Leicester astronomer Leigh Fletcher that aims to observe the entire Saturn system, its atmospheres, rings, and numerous moons. The JWST views the universe in infrared due to redshift phenomena. This makes it the ideal instrument to allow astronomers to see deeper into the universe than ever before, and also further back in time than previous instruments could. Yet, as these raw images of Saturn illustrate, the Space Telescope has also been surprisingly effective at seeing objects within the solar system in unprecedented levels of detail. This has included impressive views of the ice giant Uranus, including its icy ring system and moons, images of Saturn's fellow gas giant Jupiter and its glowing aurora, and even a glimpse of a tiny dwarf planet at the edge of the solar system with its own strange ring system. In conclusion, one thing is for sure. The James Webb Space Telescope is proving to be the most sensitive telescope ever built. The findings and discoveries in the universe have the potential to reshape our understanding of the cosmos and provide new insights into the fundamental nature of the universe. From the detection of gravitational waves to the search for dark matter and the study of exoplanets, these discoveries are opening up new avenues of research and exploration that promise to reveal even more wonders and mysteries of the cosmos. As we continue to explore and study the universe, we can look forward to many, many more exciting new discoveries that will expand our understanding of the universe and our place within it. Well, that's all the information we have for you today. Don't forget to give us a thumbs up, and if you enjoyed today's episode, subscribe if you haven't already, and hit that like bell so you never miss out on any future episodes. And be sure to tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we'll see you next time.